Hello students, so let's go for a quick revision for fluid mechanics. So in the fluid mechanics, you have to mainly focus on Bernoulli's equation, continuity equation, and little bit of this particular buoyancy forces. So these three are very simple thing. You have to just focus where how you can apply this particular problem. So in general, the continuity equation and Bernoulli's equation can be worked simultaneously. So आपको दोनों को ही एक साथ use करना होगा. So let me discuss in a very efficient manner. We have one tube and this tube is very smooth and there is not any turbulence. So the flow is very smooth, streamline flow is there. And we have suppose area A1 and this is cross section area. And here is area A2 and the velocity of a fluid, suppose this is my fluid is flowing. The velocity of fluid at this point is, let's say, V1 and velocity of fluid at this point is V2. So what we have from the continuity equation that A1 V1 is equal to A2 V2. So this equation is very important equation. In this equation, they will give that some area of cross section. You have to always keep in mind that this area is area of cross section and fluid will be just flowing perpendicular to that particular cross section. So this is very important. And so in this type of thing, you can use one variable. You can use V2. You can use V2 as a function of A1, V1, and A2, and this kind of thing you can use. But this plus next is Bernoulli's theorem. So this is your continuity equation. Continuity equation, and next we have to just go for Bernoulli's theorem. So Bernoulli's equation. So in the Bernoulli equation, suppose there is any fluid, some pipe is there, and this pipe can, and this is your some pipe, and this is your reference line is there, such that every point have different height and different pressure. So suppose we want to talk about this particular point, and we want to talk about this particular point. There is some pressure P1 here. And obviously, the pressure is acting on this direction is, let's say, P2 here. And this height is, let's say, H1. This height is, let's say, H2. And the velocity is, let's say, V1 here. And the velocity is V2. And we can take this as a cross section. So you can use the conservation of energy. So when you are going to use conservation of energy, then you can write P1 plus rho g h1 plus half rho v1 square must be equal to P2 plus rho g h2 plus half rho v2 square. So this is constant. So you can easily say that pressure, whatever you are giving the pressure, maybe sometime it has atmospheric pressure, and this is your height from the reference. So you can take this is a height from the earth, where is your pipe is, where you want to just calculate. You have this velocity v1 at the height h1. So you can have rho g h plus half rho v square is constant, and this is particularly known as Bernoulli's theorem. So what you will do, you have to use Bernoulli's theorem 2 point, this is first point, second point, as well as if you have cross section area. So then this is your continuity equation. You can use these two things, and anything you can calculate from this particular thing. And the last part I want to focus on the mainly buoyancy force. So what is buoyancy force? It is very simple concept, and we have some liquid, and in this liquid you can just submerge partially or fully some solid. So there, so due to this liquid, you have some buoyancy force. So this is your buoyancy force. I can write this is buoyancy force. So this buoyancy force is equal to rho of liquid. This is rho of liquid, volume displaced by this solid. So how much volume is going to displaced by this solid? If this solid is submerging into this liquid, then you have to see how much volume is going to displace. So this is volume displace into G. So this is volume displace. And this volume will be actual amount of the solid which is submerged into this particular liquid. So you have to always keep in mind. So this is your buoyancy force. So at the equilibrium, your buoyancy force will equate to weight of the solid. So this is your weight, and there is your some buoyancy force is, let's say this is your B. So your buoyancy force must be equal to weight. So this is at the equilibrium. And you can also try to learn a little bit else, that if you are pushing some extra force and after leaving it, it will again going to do the oscillation. So you have to also do it into oscillation chapter, and you should know how you can find the angular frequency of that particular oscillation. We will do it into simple harmonic motion, but here you have to just identify that rho is the liquid rho, and V is the displaced volume due to this submersion of solid, and G is the gravity. So this formula you have to work in a very nice manner. Just try to go in your notes, go to your book, see how these formulas are going to work. And I think out of 3 questions, 2 questions, at least 2 questions will come from this part, and you can just if you are going to focus on this point, you can easily cover it up. So this is from my side of quick revision for fluid mechanics.